Welcome to the Virginia Asphalt Center for Asphalt Technology. This is a materials certification class related to slurry surfacing, and this is the math section, so it's chapter 7 of your manuals. We're going to go through some common math that you need to do as an inspector or as a contractor to ensure the quantities that are applied as well as the payments made are correct. So let's talk about a few learning objectives. First, you're going to have to understand how to calculate unused stockpile aggregates. When you're done with the site, there's always a little bit of material left over. That material is not paid for, so we need to know how we calculate it. We need to understand how we're actually going to calculate project quantities. So how many square yards, how many tons, how many gallons. We'll go through those things. Need to understand price adjustments. Just like most materials, if materials put out of compliance, too much, too little, there is an adjustment on what is actually paid for. So let's talk about some common things that you need to compute on these projects. First, application rates. So how much material did you put down? How many square yards? How many tons? How many gallons of asphalt or emulsion? How do you calculate waste and not used material? We'll talk about that. Total quantities on a route. So on a project, how many tons of aggregate was actually used? How many gallons was actually used specifically for that route? And we'll go through some scenarios. There are price adjustments for asphalt. So for that amount of asphalt emulsion, the residual that's left over, if the application rate that is specified in that contract is not used, there's an adjustment for that. And then the same with the price adjustments on aggregate. So what are some common things you need to know for the math related to slurry surfacing? Well, first of all, we got a basic equation where R is rate. So rate, application rate, either in pounds per square yard or gallons per square yard. 9 is just a conversion. So a lot of the math we do is in square feet, but a lot of the quantities are in square yards. So that converts us between square feet and square yards. T is that total weight. Total weight of slurry surfacing, total weight of latex modified emulsion treatment. Width of the road, and in this case, when we're calculating application rate, instead of road, we're talking about a standard plate or a standard burlap bag size. And we'll go through that because it's important to know over what area. The same with the length, over what area are we checking to make sure that that distributor is applying the material properly and the aggregate is being applied properly. So we'll go through that. Again, with latex modified emulsion treatment and with slurry surfacing, it's combined. It's aggregate and emulsion together. So unlike surface treatment, we don't do 2 different shots. It's one time. Whenever we're laying asphalt, it's one time. Well, with latex and slurry surfacing, it goes down once, so we need that pad or we need that plate to make sure that the application rate is correct. So let's go through a couple scenarios, and this will help you understand the process. It's pretty simple, it's pretty straightforward. Most inspectors and even contractors can have a standard size plate, standard size bag. In this example, it's 2 feet by 2 feet. You want enough area to collect the material. You weigh the plate, you record the plate weight in pounds. You have your surface treatment, your slurry surfacing or your micro latex modified truck drive across the plate, and then you pick the plate up and you weigh it again. So you have a bare plate, an empty bag, you lay it down, the truck drives over, you pick it up and you reweigh it, and in this case it weighed 12.5 pounds. So we started with a 3-pound plate. Once the slurry's on it, it's now 12.5, so we need to calculate our application rate. Well, remember that simple equation, R equals 9 times T divided by length times width. Well, T is our final weight minus our initial weight. So that 12.5 is what that plate or that bag weighed after the truck went over it. 3 is what it weighed before we applied any slurry to it. So it weighs 9.5 pounds. We have a 2 foot long by 2 foot wide, so it's 4 square feet. So we just plug everything into the simple equation. 9, remember that's that conversion factor from square feet, because that's what everything we're talking about, square feet, square feet. Now we got to convert it to square yards, because that is what our specs are written in. That's what our application rates are based on. 9 times 9.5 divided by length times width, 2 by 2. And when you do that math, the final rate is 21.4 pounds per square yard. So just take your calculator, take 9 times 9.5, divide that by 2 times 2, or 4. And you should get 21.4 pounds per square yard. Now, the question you could see on the test is, does this meet spec for a type F or a type C? Well, now's when you got to go back and look in the specs. That was one example. Let's look at another example. Again, we're trying to make sure, does that a contractor's equipment put down an application rate of slurry or micro that meets specification? So, another example, now we're starting, instead of a plate, we have a bag. The bag's 3 feet by 3 feet, so a little bit bigger, weighs 1.5 pounds. The truck passes over that bag again, and when it's done, now it weighs 16.5 pounds. So, what's the application rate? Same basic formula. 16.5 is what that bag weighed with the emulsion on it and the stone and everything. 1.5 is where we started, so now we've got 15 pounds of that slurry surfacing. Our bag is 3 feet by 3 feet, so let's just plug everything into this formula. Remember, 9's our conversion, so 9 times 15, which is the total pounds that we applied, divided by 3 by 3. So just plug it into your calculator, 9 times 15, divide that by 9, and your rate's 15 pounds per square yard. So now if we're using a type A slurry surfacing, look in your specs, does 15 meet the spec requirements? So that's what you're doing out in the field. All right, so now let's calculate how much aggregate waste is left over when a project is completed. So when you're typically done with a project, there's a little bit of material left over. That material is not paid for. So how do we calculate what remains? Well, first we want the contractor to put that excess material in a conical pile. It's not going to be a perfect cone, but we want them pretty circular. We want it pretty piled up so we can estimate how much material is in there. We also need to know from the contractor what that material weighs, what's the unit weight, how many pounds per cubic foot. We'll talk about why that's important, because that's how much we're going to figure out how much of a stockpile is not really used on a road. So let's walk through this. First, you got to be able to measure how big that conical pile is. So what's the circumference of it, as well as what's the height. So you probably will take a measuring wheel or some type of measuring device, go around the pile, and then you'll also estimate how tall that pile is. You also need to know the unit weight, so you're going to ask for that information from the contractor. It varies across the state depending on the aggregate source, because some materials in the northern part of the state weigh a lot more than those materials in the southern part or even in the western part of the state. Then you got to determine how much volume is there. So in that leftover pile, how much was left over so we can estimate the weight. Well, first thing you need to know is, how do you calculate the volume of a stockpile? Well, we need to use a volume for a stockpile. If we assume it's a cone, which is not going to be perfectly, but that's the best estimate we can come with, we use this formula, which is just simply the circumference squared times the height, and this is all in feet, divided by 12 pi. 12 is a conversion factor, and pi is 3.14159. So you have all the information you need to calculate how much volume of material wasn't used. So let's go through an example, and it'll make a little bit more sense. So let's assume we've just slurry sealed Route 124. And when it's done, we've got some material left over. The contractor's piled it up. We've got sort of a cone. It's sort of circular. Let's estimate how much material is left over. Pile's about 4 feet high. It's about 20 feet round. We also know from the contractor that this material that was used is about 108 pounds. So we need to know that so we can convert the number of, or how much volume over into tons. And we'll step through that and it'll make more sense to you. So how much aggregate was not used? We finished the route, what's left over? Again, let's go back to this simple equation. We know that the circumference is 20 feet. We know the height is 4 feet. So when we plug in 20 squared times 4, divide that by 12 pi, you should get 42.4 cubic feet. So again, take the circumference squared times the height of that pile, divide that by 12 pi, and you should get 42.4 cubic feet. So that's how much volume of material, but that's not how much it weighs. So you got to convert that now over into tons. So you got to know the unit weight. So that aggregate that you're using, what's the unit weight? And it's in a term called pounds per cubic foot. You'll have to get that from the contractor. Sometimes your materials division or your materials section will have it, but for that material you're using, what's the unit weight? You got to have that estimated volume. So we just estimated 42.4 cubic feet. To get the weight of that aggregate in the stockpile, weight is volume times unit weight. So volume we estimated. Unit weight is what that material weighs. And then we just need the 2,000 converted over to tons because we're looking at how many tons of material to pay for. So let's continue to walk through this. 124 was slurry sealed. We've got some material left over. There's our height. There's our circumference. We know that aggregate weighs 108 pounds per cubic foot. So how much aggregate was not used? All right. So weight of the stockpile aggregate, if you remember our volume was 42.4, now it's volume of 42.4 times the unit weight of 108, and then we divide that by 2,000 because that now converts it from pounds per cubic foot over to tons, and we only had 2.3 tons of material left over. So let's just go through that one more time to make sure you've got it. We calculated our 42.4. Remember that 20 foot around circumference, 4 foot high pile. We estimated it was 42.4 cubic feet was in that pile. Once we know that, we just have to convert it over to tons. To do that, we need the unit weight of that aggregate. So 42.4 times 108, and then take that value, divide it by 2,000, and you'll get 2.3 tons. So that's how many tons was left over when we were completed. Let's look at another one, and now we're going to just walk through the steps one more time to make sure you're clear. 95 got a latex modified emulsion treatment. So we're out on 95, the project's over, we got another pile of material. Not everything was used. A little bit bigger pile, 7 feet tall, 33 feet around. A little bit heavier aggregate. Maybe this is a project a little further northern in the state, but now it's 111 pounds. Let's start calculating what we need to know. First, let's look at the volume of that stockpile. Same equation. So all you need to do is plug in the new numbers. C now is 33. H now is 7. So using your calculator, 33 squared times H, which is 7, divide that by 12 times pi, and you should get just over 202 cubic feet of material left over. Okay, now that we've calculated the cubic feet of material left over, now let's just convert it over to weight, or how many tons we didn't use. So same information on this project. We've got the pile height, circumference, we use that to come up with the volume. We know it's 111 pounds per cubic foot. So how much aggregate did we not use? So let's look at that weight of that stockpile. Let's look at that simple equation of weight is volume times the unit weight of the material divided by 2,000. Again, that 2,000 takes these from pounds over to tons. We had 202 cubic feet not used. So that's how big that conical pile is, that volume. 111 was our unit weight. We divide that by 2,000, and we calculate 11.2 tons. So we had 11.2 tons of material, of aggregate left over on this project. So let's determine project quantities now. What do we need to know? How long a route is, how wide the road is. Does the road change? Is it part of it 20 feet and then it bumps out to 22 feet? Are there any cul-de-sacs? A lot of times we'll use slurry surfacing in subdivisions that have cul-de-sacs. And how about tie-ins? Do we have a lot of tie-ins where we have to pull back on the road a little bit just to make a good transition? Because this will add a little bit more material to the final quantities on a project. Simple route with minimal tie-ins and no cul-de-sacs is really the easiest one to calculate. When we're doing it, if we're doing latex or if we're doing slurry, it's length times width times rate divided by 2,000. Again, this is to get it over into tons, length of the route in feet, width of the route in feet. The application rate that we've calculated is at 16 pounds per square yard, 17 pounds, whatever it may be. The 2,000 takes this rate, converts it over to tons, and this 9 takes this length and width that's in feet and converts it over into from square feet to square yards. If we're just looking at slurry itself, where we're calculating stuff in square yards, because latex is in tons, slurry surfacing is in square yards, we just need length times width divided by 9 to calculate how many square yards of emulsion was applied or how many square yards of aggregate. If we got a cul-de-sac, we just need to account for the circle at the end. Please realize this isn't going to be perfect because you have a little overlap area. A lot of times these may not be perfect circles, but again, it's to give us a really good idea on the estimated quantities. Again, the only difference is if we're doing tons, we have to do length times width times rate for the road part. And then pi, which is at 3.14159, times the radius of the cul-de-sac, 20 feet, 30 feet, whatever it may be. Again, times the application rate of your latex. And again, we don't normally do latex at all in subdivisions. But if a route happened to call for it, we're showing you how it's calculated. And then the 2009 converts it over into tons and square yards. If it's the slurry surfacing, which is more common on routes that have cul-de-sacs because it's usually in subdivisions, it's length times width for this part, pi r squared for the cul-de-sac, and then we just divide it by 9 to get from square feet over into square yards. So let's do a simple type of calculation. We'll assume it's a latex modified type B, 16 pounds per square yard, and we want to calculate how much was actually used. So how many tons did we actually use on this project? Well, latex, the calculation is length times width times our rate, and our rate was told to be 16 pounds per square yard plus pi r squared divided by 2,000 times 9. This route is 4,200 feet long, so it's not a mile, about 0.8 of a mile. It's 18 feet wide. The radius of the cul-de-sac at the end is 20 feet. We know 16 pounds per square yard is what we were given. And when we take all these values and plug it in, 4,200 times 18 times 16 plus pi, which is 3.14159, times our radius, which is 20 feet squared, times our application rate of 16. When we put all that into our calculator, we see it's 68.3 tons of material was applied on that route. If it was a slurry type B, again, now we're just calculating how many square yards. So the rates really drop out. So it's length 4,200 times 18, so 42 times 18 plus pi r squared, so 3.14159 times r, which is 20. And we divide that by 9 to get it from square feet over to square yards, and we get 8,540 square yards. And again, that's how we convert it all over and calculate it. So like most materials, we also have price adjustments. So with slurry surfacing and for latex, we have adjustments based on the asphalt that was actually applied and the aggregate. So let's first talk about the price adjustment for asphalt and slurry surfacing. What do you need to know to be able to do these calculations? First, you need to know slurry seal is based on the total asphalt used and the residual asphalt content. The asphalt that's used as an emulsion is a combination of water and liquid asphalt. As that water evaporates away, residual asphalt's left behind. So we're not going to pay for the water that evaporates. We're going to pay for the amount of liquid that's left behind. So we need to know what that residual is. Total asphalt and residual asphalt is provided on the weigh tickets. So how much emulsion? Was it 3,000, 5,000, 7,000 gallons? And in that gallons, what percentage of it was asphalt versus water? So is it 65%, 66%, 64%? All that's provided to you on the certified weigh tickets. You have to know what's the AC content in that approved job mix formula. So is it 9%? Is it 9.5%? Is it 9.2, 8.7? You need to know that as well. You need to know total tons of aggregate used on a route. So that's why we went through the calculations to see how much was left over or not used in that total calculation. So it may have 3,000 tons set up for that route that was going to be used, but maybe we only used 2,950. Our calculations need to be on the 2,950 and not on the 3,000. So that's why we went through that exercise to calculate how much material was left. And then the actual AC contents determine total residual asphalt by the total tons of aggregate used. Price adjustments are based on the actual versus the job mix AC. What was our percentage that we actually used compared to what was in that job mix that got approved? And if there's a difference of more than 1%, so we say job mix AC tolerance of 1%, whenever you're below that 1% tolerance, for every tenth, there's a price adjustment. So we'll go through that. So if the job mix formula was 9.2 and we were no less than 8.2, there's no price adjustment. But if we're at 8.1 or 8.0, we're below that 1% tolerance. And now for every tenth below that 1% tolerance, we do an AC or a price adjustment. So we'll go through that. So let's look at an example for slurry surfacing. Route ABC was slurry sealed, type C. 177 tons of residual asphalt, 2,300 tons of aggregate was used on that route. The job mix formula was 9%. Is there a price adjustment needed? And if so, what was the difference between the actual and the job mix AC content? So first, we need to determine how much AC, what was the actual AC content? We have our residual and we have our total tons. So our actual is 177 tons of asphalt binder was used. We had 2,300 tons of aggregate, so our actual in the field was 7.7%. Our approved job mix called for 9%. So what does that tell us? It tells us that we do have a price adjustment. So 7.7, that's more than 1% below the tolerance. So a price adjustment is required. The actual is 0.3% less than that tolerance of 1%. So now we know that it's 0.3. We have to take that into our price adjustment. If we look into the spec, it says you're basing it on the contract unit price. The contract cost was $2.30 a square yard. By specification, it's a 1% reduction in square yard cost for every 0.1% below. So we were 0.3 below with a 1% reduction. So how do we do that math? We got that 0.3% difference. The price adjustment is the contract cost times this 1% in the spec times 3, because we were 3/10 low. For each tenth low counts as 1, and since we were 3/10 low, it counts as 3. So let's plug that information in. We know it was $2.30, 1%, multiply it by 3, and you should get 7 cents. So now we adjust every square yard by 7 cents for AC content. So now our adjusted contract price is $2.23 per square yard. So now we've looked at the AC content, but we'd also do adjustments on aggregates if the aggregate quantities aren't correct. And it's a very similar process. What do you need to know? Slurry seal, we also looked on total aggregate applied. You need those weigh tickets again, but don't include that waste material. That's why we calculated how do you determine the amount of waste on a project. You got to know the application rate for that route. What was set up? How many pounds per square yard? Actual application rate. So the contract may say 18 pounds per square yard, but what was actually applied by the contractor? And to do that, we got to figure out our quantities. So the spec says the price is adjusted per square yard for every pound below the contract rate. So if our contract rate is 18, but we only applied 16, we're in a price adjustment. And for every pound, there's a 3% price reduction per square yard. So let's go through a calculation to see how that works. ABC got a slurry seal. We know it was 32,736 feet. It's 24 feet wide. Contractor applied 66 tons of residual asphalt and 786 tons of aggregate. The job mix called for 9% AC. The contract specified an application rate now of 20 pounds per square yard. Now let's go through and let's figure out, do we have a price adjustment? So to figure out the price adjustment for a slurry surfacing or a slurry seal, we got to know what was the actual versus what was specified in the contract. First, we got to figure out how big of an area that we used. So we know that that route was 32,736 feet long. It's 24 feet wide. We have to convert that to square yards, and when you plug those numbers into your calculator, you should get 87,296. We got to convert the weight that we used from tons to pounds. We used 786 tons, so we just multiply that by 2,000, and we get 1,572,000 pounds. So now we know how many pounds, we know the number of square yards. We can calculate the application rate by taking the total number of pounds divided by the total number of square yards, and it turns out that we only applied 18 pounds per square yard. So now let's compare that back to our requirement in the contract. Based on 18, do we have to do a price adjustment? Well, let's look on the next page and we'll figure it out, because if you look in the spec, remember what we said is a 1 pound tolerance, and when we're 1 pound below, what do we have to do? Well, we're actually 2 pounds less. So we specified 20, but we only applied 18. So now we have to adjust again that unit cost. Contract cost on this project was $2.52 per square yard. There's a 3% reduction for cost for every pound below the specified rate. So now we take our contract cost, $2.52, that 3%, and now we're 2 pounds below. We take our contract cost, multiply it by 3%, and since we're 2 pounds below, we take $2.52 times 0.03, or 3%, multiply that by 2, and now we have 15 cents per square yard reduction. So the contractor is not going to get paid $2.52 per square yard. We calculate it, they only get $2.37. Why? Because they didn't apply the amount of aggregate that was required in the contract. So they bid $2.52 based on 20 pounds, but since they didn't apply 20 pounds, you have to adjust that unit cost, and it's $2.37. And that's how it's calculated. Reality, now on project, you have both aggregate and asphalt that you have to account for. So let's run through this project again with some other scenarios. We got route ABC again. We're getting a type C slurry. This route's 19,800 feet long and it's 28 feet wide. Contractor applies 40 tons of residual asphalt and 524 tons of aggregate. The job mix formula in AC content was 9%. So we know that's what we need in terms of determining if there's an adjustment necessary. The overall application rate was 20 pounds per square yard. So we need to know, did we get enough aggregate? And the contract cost was $2.75 per square yard. So now on projects, really what you're having to look for is the asphalt content and the aggregate. Is a price adjustment needed? So let's go back to good old route ABC. First, we're going to adjust the asphalt content. What do we need to know? What was the actual? Remember, actual is taking the residual, divide that by the tons of aggregate used, and when you take 40, divided by 524, multiply by 100, it's 7.6%. What do we know? Well, based on the spec, at 7.6%, a price adjustment is required. So how do we do that? Since we're 4/10 below that 1% tolerance, we take that equation where we look at the contract cost was $2.75 a square yard. There's a 1% reduction for every tenth below that tolerance. So now we're 4/10 below that tolerance. So the adjustments that contract cost of $2.75 times 1% times 4. So if you multiply that all out, it ends up being 11 cents per square yard reduction. So just on the asphalt content, we need to adjust our overall price by 11 cents per square yard. But we also need to look at the aggregate. So let's adjust for that, see if there's an adjustment needed. We got to determine how much surface area, because again, with slurry surfacing, we're looking at surface area. So the route was 19,800 feet long, about 3.5 or so miles. It was 28 feet wide, so 19,800 times 28 divided by 9 is 61,600 square yards. So that's how much area that we actually applied. We know that we did 520 tons. Multiply that by 2,000, we get 1,048,000 pounds. So now we know how many pounds, we know how many square yards, we can calculate our application rate to be 17 pounds per square yard. And again, that's just taking the total number of tons we used, divided by the number of square yards that we applied, and it turns out that we applied 17 pounds per square yard. This application rate we know is now 3 pounds less than what the contract required. So now we have to adjust for the aggregate. And since there's a 3% reduction for every 1 pound below, now we got to adjust for 3 pounds. So it's the contract cost times 3%, and it's 3 pounds low. And we know that this was $2.75. So now our price adjustment is $2.75 times 3% times 3, or now it's 25 cents per square yard reduction. So now we've calculated our asphalt content reduction and an aggregate reduction. We didn't apply the amount of asphalt that was required in that contract by the job mix formula that was approved, and we didn't apply the number of pounds per square yard of 20 that was in that contract. So now there is an overall price reduction. The total price adjustments, first you got to combine them together. So what was the asphalt and the aggregate? We calculated it as 11 cents for the asphalt. It was 25 cents for the aggregate. So that's now 36 cents. We just add them together. And for that project, determine the total price, we just take the $2.75, that bid item, subtract 36 cents, and now the contractors paid $2.39 per square yard. So latex modified, same but a little different because we're looking at tons as opposed to square yards. So what do you need to know for latex? Again, you got to know total asphalt used and residual, because we're going to look it back to our job mix. We got to have certified weigh tickets. You got to know that JMF approved job mix. A lot of the same things we just talked about for slurry surfacing. How many tons that was used on a route. Actuals determined the same way, total residual by tons used. See how the process is very, very similar. Adjustment same based on actual versus job mix. We're adjusting for every 0.1% below that 1% tolerance. So let's go through this and do the same type of calculation. Route ABC has a type C latex. Contractor used 200 tons of residual asphalt and 2,400 tons of aggregate. The JMF for this mix was 9.5%. Was a price adjustment needed on that route? And if so, what's the difference between the actual and the job mix formula? So first, let's look at the actual is residual divided by tons of aggregate. So it's just 200 divided by 2,400 tons. Says that we had an actual AC content of 8.3%. Our job mix was 9.5%. So we need to do a price adjustment. So based on the 8.3, price adjustment is required. We're at 1.2% less than the job mix of 9.5%. The price adjustment is based on that 0.2% beyond that 1% tolerance. What does that mean? You take 9.5%. You subtract 1, you're at 8.5%. Our actual is 8.3, so now we're just 0.2 lower than that. So we have to take that into account when we do our calculations. The contract cost was $2.30 a ton. So unlike slurry surfacing where we were bidding it based on square yards, latex is based on tons, so we have to adjust based on that tons of material. At 1% reduction in cost for every 0.1% below that tolerance. Same type of approach. Our contract cost was $230 a ton, 1% by spec, and since we were 0.2 below the 1% tolerance, we just multiplied all together, and it's $4.66 per ton reduction. So the contractor's not going to get paid $230 a ton. You got to subtract $4.60, and now they get $225.40 per ton based on the AC content. Because the AC content approved was 9.5, but they actually only did 8.3. Very straightforward. The calculations are very easy to follow. There's plenty of examples in your book. If you have any questions, please ask your facilitator. Thank you and good luck.